Today we're going to work on Lesson 22, Uniform Motion Problems. These problems are going to be done with equal distances. We're going to do a variety of uniform motion problems this year. These are the easiest because the distances that the people travel are both going to be the same. The basic thing you have to remember is the distance formula right here. You need to memorize this. Distance equals rate times time. We'll use this over and over all year. Just keep that in your head. Distance equals rate times time. So let's look at our first problem, example 1. Roger made the trip on Sunday. You don't need to write this down. Just follow along with me. Roger made the trip on Sunday and Judy made the same trip on Monday. Right there where they're talking about the same trip, we know that the distances are going to be the same. The distances that they travel are going to be the same because it's the same trip. Roger traveled at 12 miles per hour and Judy traveled at 20 miles per hour. So her time was 2 hours less than Roger's time because she was going faster. How far did they travel? So to start this out, we know it's going to be a distance problem. So right away, if it's a distance problem, we need to make one of these diagrams. So I'm going to take and make my diagram. Just draw these two parallel lines. And we have the two distances. We have the first distance is going to be Roger's distance, and we're going to use subscripted variables. So his distance is going to be d sub r, which will stand for distance Roger. The next one is Judy. Her distance is the same, so we're going to draw in her distance. And we're going to call this distance J for distance Judy. When you're doing these equal distance problems, we can set their distances equal. So the distance of Roger is going to equal the distance of Judy. This doesn't help us much, but if we translate distance into rate times time, we'll have some information to solve the problem. So we're going to take our distance of Roger and we're going to change it. If you notice over here we have distance equals rate times time. But we have to distinguish between the rate of Roger versus the rate and time of Judy. So it's going to be the rate of Roger, time of Roger, that's his distance. We're just substituting. Instead of writing distance Roger, we're going to rate times time of Roger, equals the rate of Judy, time of Judy. So this is the basic equation that we're going to work with. Most of your equal distance problem, it's going to end up looking like this. Rate of Roger, time of Roger equals rate of Judy, time of Judy. Different names, same equation. So let's go back to our problem and see what kind of information the problem has given us. First of all, it tells us that Roger traveled at 12 miles per hour. When you talk of miles per hour or kilometers per hour, that's going to be your rate. So we know that the rate of Roger is equal to 12 miles per hour. Let's see what else we know in this problem. We know the rate of Judy. Her rate is 20 miles per hour. So we can write that down. Rate of Judy equals 20 miles per hour. So we have two pieces of information. You'll notice we have 4 variables in one equation. We needed to get it down to 1 variable in 1 equation. So let's look at what else we have. We have her time, Judy's time, was 2 hours less than Roger's time. So we can do something for time here. We can say, find my sample, we can say the time of Roger equals the time of Judy plus 2. His time is 2 hours more than hers, so there's a stink bug in the room. So we have to add 2 to Judy's time to make them equal. So now we have some information and we're going to plug it back into our original problem. So we have the rate of Roger is 12, so I'm going to put that in for the rate of Roger. The time of Roger, we know is the time of Judy plus 2. So we're going to put that in here. We have the rate of Judy is 20. And we don't know the time of Judy, so we can put TJ, time of Judy. So now we have one equation with just one unknown, and that's what how we have to get it before we can solve it. So this is our basic setup. You're going to write your rate times time equals your rate times time. You're going to write down everything that you can figure out from your words, and then you're going to plug it into your problem. Now we're going to solve for the time of Judy. So we're going to distribute. We're going to get 20 time of Judy plus 40. That's an awful J. We're distributing equals 20 time of Judy. Oops, something, okay. Something went wrong there. What went wrong? 12. Whoops, this should have been 12. Oh, it's terrible to mess up on camera. 12, and then this would be 24. So we're going to get all our TJs on one side. So we're going to get 8 time of Judy equals 24. And we're going to get the time of Judy equals 3. That's not everything we need, though. We know the time of Judy is 3 hours, but you have to go back and see what the question's asking. It wants to know how far they traveled. So we need to go back up here, and we know that the distance equals rate times time. So let's just pick Judy's distance. So the distance of Judy equals the rate of Judy times the time of Judy. So the distance of Judy, we know Judy's rate is 20, Judy's time is 3, so she traveled for 60, is it in miles? 60 miles is your final answer. So hopefully that made a little bit of sense to you. So let's look at example 2.